All right, so we're in geometry. We are doing some Algebra 1 review. This is an Algebra 1 unit. Unit 16, we're talking about quadratics in this unit. Again, our unit looks like, not that, geometry, there we go. We have 10 lessons, 2 quizzes. I had to shorten the Khan Academy content, which means our quizzes cannot be on Khan Academy. They have to be on paper because Khan Academy doesn't allow me to not put stuff on quizzes. So because I'm skipping over stuff, all of our quizzes and tests have to be on paper. All right, so we have a ton of vocabulary like we do with every unit. Today's date is Monday, April 22nd, 2019. Make sure you have your name and date on the notes. Here is a graph of a quadratic. This shape is called a parabola. Write it down. It is a parabola. Parabola. A key feature of a parabola is its vertex, that very bottommost point, or the very topmost point if it's flipped upside down. This point right here, I'll scroll down so that you guys can see this. This point right here is called the vertex. Label it. Vertex. This vertex is a point, and a point, as we remember from Algebra 1, is just, it has an X coordinate and a Y coordinate. This vertex has a coordinate of -3, -2. So I'm going to put that down, -3, -2. That will be important for today's lesson because we're going to be talking about vertices, especially tomorrow too, that they have just, it's a coordinate, X coordinate, Y coordinate. All right. This parabola also has a line of symmetry. You guys can probably guess where that's going to be. If I had to fold this paper in half somewhere, where would that line of symmetry be so that they overlay on itself? So where does it fold in half perfectly? It's obviously not right there. It's going to be right here. This is called the axis of symmetry. Write it down. Axis of symmetry. The other thing that we need to know about this parabola is that it technically goes on forever and ever. The arrows got cut off, so please put them back on here. This arrow says it goes on forever and ever to the top left, forever and ever in the top right. And because my arrows are pointing up and not down, I say that this parabola opens up. Not down, but opens up. If I have a parabola that's going the other direction, say some parabola that looks like that, that would be opening down. So we can do an example over here. If you want to do a quick example, this opens down. All right, what else do we have on this parabola? Things that we know for sure. We have a y-intercept, we have x-intercepts, so let's label the y-intercept. So this point that it crosses the y-axis right here, that is called the y-intercept. Y-intercept. We also have some x-intercepts down here. It's where it crosses the x-axis, so label those. We have an x-intercepts here and here. X-intercept here and here. So those X-intercepts have different names depending on what I'm talking about, and there's actually a poster underneath the PEMDAS if you look on the wall, right behind Chewy. So if Chewy gets in the way, he can block everything if he wants. But in terms of a graph, they're called X-intercepts. If you're looking at just an expression, these things would be called zeros. If you're looking for an equation, they would be called roots. If you're looking at other things, they're called different things. That's kind of tomorrow's lesson. But just know if I'm talking about zeros, I'm really talking about x-intercepts. So let's just write down zeros up above because I will be talking about that today. Sometimes we call these things zeros if I'm just looking to solve an equation. All right, so how to find the vertex, and this is going to be built on tomorrow. Today I'm only asking you about x coordinate of the vertex. Tomorrow I'm going to be doing x and y coordinate of the vertex. So on this parabola, the x-intercepts were a little bit weird. Let's pretend we have a new parabola. My new parabola has x-intercepts at x equals 1 and x equals 7. I want to know what the x coordinate is of the vertex. Notice that the vertex is halfway in between those 2 points. How am I going to find that? Anyone have any ideas? How do I find the x coordinate of the vertex? It's going to be somewhere on this axis of symmetry, and it's going to be perfectly in between the two x-intercepts. Anyone have an idea? Not a one of us? Uh-oh. All right, here. Oh, yeah, go for it, Ellery.
Well, just from looking at the graph on here, I can assume that the x-coordinate is 4, but I'm not sure if there's an actual way to find that.
There is an actual way to find it. But yeah, I mean, let's do it the kind of kindergarten-y way of writing out a number line. So if I have a x-intercept here at 1, and write this down with me, and an x-intercept here at 7, then I just keep jumping towards the center. So if I have 1, then 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. If I start at 1 and 7, so I'm going to put starting points here and here. If I jump in twice, 1, 2, 1, 2, I get really close. And then if I jump in one more time on each side, once and once, you see that the exact middle is 4. 4 is halfway in between 1 and 7. So you can kind of just eyeball it. You can use a number line, but there is an actual way to find the x-intercept faster than just using a number line. And the key word here is average. Does anyone remember how to find an average? India?
You add all the numbers together and you divide by the number of numbers.
Exactly, yeah. So how would I find the average of 1 and 7? Can you tell me exactly what to write?
You do 7 plus 1 equals 8.
Yep, so that's going to reduce to 8.
By 2.
Yeah, 7 plus 1 divided by 2, and that reduces to 8, as you said, over 2, and 8 over 2 simplifies to 4. And there it is. So you can find the x-intercept really easily by taking the average of those two x-intercepts. So I'm going to put in yellow. You don't need to write this if you don't want to, but I like thinking of it as the average of the x-intercepts. Mainly, you just add them together and divide by 2. We're going to be doing the same thing over and over, so be ready for it. You're only going to do like 1 or 2 problems today on the homework, but tomorrow you're going to be doing tons of these. All right, the main thing that I want to take away from today isn't the vertex, it's actually the zero product property. So I'm waiting for people to finish writing, and I guess I should come back here and start keeping track of who has participated so far. This is Algebra 1. Let's go back to Geometry. And then India and Ellery, I think I deserve your cards because you participated. Ellery and India, you are in, and I will get the marbles out after I ask this question. So this is for you guys. If something, Beverly, times something else, A times B is 0, what do we know about A and B? So you're thinking about this to yourself. What do we know about A or B? What do we know about A and B? And turn to your neighbor and talk. What do you know? See if your neighbor knows. See if your group knows. All right, let's see hands. How many people have an answer? What do we know about A or B? What do we know about A and B? What do we know? And even if you didn't know before, but you heard it from someone else, I still expect a hand. Beverly?
A or B is 0?
Yep, write down. A or B is 0. One or the other is 0. And maybe both, right? It could be A and B both happen to be 0. Because 0 times 0 is definitely 0. Thank you, Beverly. Mathematically, what we have to do is we have to assume the worst case. Maybe A and B are both 0. So mathematically, that means this. And this is really the key thing. A equals 0, B equals 0. Make sure you definitely have this thing written down. A equals 0, B equals 0. We assume the worst case scenario in mathematics that they're both 0. Okay. So that's our basic, I don't know, 2nd grade property. I don't remember when you learned that. But now I'm going to make that a little bit more advanced using polynomials. All right, so Martine, Chewy, Jaden, I can be calling on you. Be ready to be called on. So now I'm going to change it. Instead of A times B equals 0, let's say A was my blue, X plus 1 is my blue. Instead of B, I now have 2x minus 4. So now x plus 1 times 2x minus 4, what do we know about x plus 1 and 2x minus 4? It's the same question in a different wrapper. Martine. So that's just for the top problem. It's coming down here. It's a brand new problem now. Just knowing x plus 1 equals 0, or sorry, x plus 1 times 2x minus 4 is equal to 0. Using this knowledge that I just wrote down, Martine, what do we know about x plus 1 and 2x minus 4? Say it louder. Not just x, but the whole quantity, right? This x plus 1 is equal to 0. All right, yeah, thank you. And you can turn in your card as well. So instead of changing it to a equals 0, this a has now been changed to an x plus 1. So x plus 1 is our new a. That needs to be set equal to 0. And then Martine, can you do the second half for me to get your full participation in? What else am I going to write in yellow here? If I used to write b equals 0, but now I'm going to write what equals 0? Exactly. Yeah, thank you. 2x minus 4 equals 0. I have to do both of them, and I don't know why that random one looks like a heart. Let me come back here and delete that and make it an actual 0. All right, thank you, Martine. And then from there, I have two equations. Those two equations, I need to solve both of them, and I'll have two different answers. So x plus 1 equals 0, I'm going to subtract 1 on both sides, and I get x equals negative 1. On this one, it's a little bit harder. Can someone help me out with a quiet raised hand? What am I going to have to do to both sides in order to solve for 0? I have one hand. I have two hands. I have three hands. All of those three hands don't have a card. Oh yeah, Sam, go for it. Add 4 to both sides. That'll cancel out the 4. And then what do I do next, Sam? Then divide by 2. So divide by 2. There it is. X equals 2. Thank you, Sam. Yeah, so I have two answers. My two answers are x equals negative 1 and x equals 2. Both of those things will make it so that this equation is set equal to 0, or this side of the equation is set equal to 0. So box those two answers, because we're going to be boxing those answers over and over again. X equals negative 1 or x equals 2. So thank you, Sam. Let me give Martine his marble. Sam, your marble. All right, so same type of problem. I have two things multiplied together set equal to 0. I'm looking for the solutions. What are the solutions? How do I find them? Can someone help me do the first step? How do I find the solutions to this equation? India's ready to set it up. Who else knows what to do? We're using the zero product property. Chewy, go for it. It's like the last one, yeah. And there it is. Thank you, Chewy. Yeah, you set it up perfectly. You set both halves equal to 0. All right, and then from there, I need to solve both sides. Everyone should be comfortable doing that on your own. You will get a fraction for one of them. Thank you, Chewy. Go ahead and do that now. Solve both of these two equations. I have a blue equation and a yellow equation on mine. Solve both of them. Box your two answers. Let me see what you got. Nice, yeah. Just gotta solve the left one a little bit more. Solving both sides. All right, after you solve it, check with your neighbor, make sure they got the same answers that you did. I need a quiet raised hand. Who can help me solve the blue equation? Who can help me solve the blue equation, the left equation? I want to call in someone new if possible, but if not, we got some good backups. Yeah, Caroline. All right, and then you get 3x is equal to negative 5, then what? Yep. Divide both sides by 3, and we get, yep, just leave it as a fraction, negative 5 over 3. Thank you, Caroline. You want to do the other one really quickly for us as well? Yep, and you get, there it is. Yeah, thank you, Caroline. All right. And then from there, we have our last example. This is another way of asking the same type of question. Find the zeros. As I said up above, the zeros or the x-intercepts, or I guess in this case the solutions, those are all the same word. So what I'm going to do here is I'm going to change this f of x, which could have been written as y equals all of this stuff. I'm going to change that to a 0. So I'm now going to rewrite this as 0 is equal to negative 4x minus 1 times the quantity of 3x plus 2. All I did was I rewrote the f of x as a 0 because I'm finding the zeros of the f of x. From there, I solve by setting both equal to 0. So I want you to do that on your own. Find the answer,